in this lecture, I'll show you some another type of special case. So here it is coming, integration dx by outside linear and under root over it is quadratic. So the general, just see one thing, we can substitute and we can solve the sum. There is some number of ways, I'll show you, but the general way is that outside is some of the linear equal to 1 by t. So I am giving you one example. Suppose integration dx by x into root over x square plus 2x plus 3. How to solve this? Let's see. In this case, outside the root over in the denominator is linear. This is the form, linear quadratic into root over quadratic form. So what we'll do here, we'll take linear x equal to 1 by t. So dx equal to minus 1 by t square dt. So dx के जगह में I am writing minus 1 by t square dt. X is 1 by t and root over of 1 by t square plus 2 by t plus 3. So one number of 1 by t is getting cancelled and another 1 by t is coming. That is why it has been taken, so that it will be adjusted and 1 by t part will be cancelled. And if I just go through this, we are getting dt by, once again if it be the whole square, this is 1 by t 1 present, and here 3t square plus 2t plus 1 by another root over t square, and it is coming. Another 1 by t is cancelled and a coefficient over and I am solving this up. So I am taking minus 1 by root 3 outside and dx. What will get here? What will get here? In this case, root over of t square plus 230 plus 1 by 3. So absorb all that to make a whole square. Therefore, we are getting here minus 1 by root 3 and root over dx by t square minus plus 2 ab term ka 2 by this plus 1/3 square balanced by minus 1/3 square plus 1/3. So we are getting here minus 1 by this thing dx, that is root over of t plus 1/3 whole square, and this portion left appearing. This portion, okay, just calculate this portion, and if we calculate this portion, we are getting what? 1/3 square, that is 3 by 9 minus 1 by 9, that is 2 by 9, that is plus root 2 by 3 whole square. If I now take t plus 1/3 equal to p, if you now take t plus 1/3 equal to p, what we are getting here? dt equal to dp, therefore minus 1 by root 3 dp by p square plus root 2 by 3 whole square. So dx by root over x square plus x square, log of x plus root over x square plus x square. So these type of sums are generally coming in the board examination. So minus 1 by root 3. So log of in one CBSE examination, it was a sum. So this is p plus root over of p square plus 2 by 9 plus c, 2 by 9 plus c. I am going to some another question. Suppose one more question. Dx by x plus 1 into root over of x plus x square plus 2. Same thing, it is in the form of dx by linear plus into root over of quadratic. So linear equal to 1 by t, which we have to take. Therefore, x plus 1 equal to 1 by t. So dx equal to minus 1 by t square dt. So I can write here minus 1 by t square minus 1 by t square dt, x plus 1 की जगह पे 1 by t, and everyone x equal to 1 by t minus 1. I can write from here x equal to 1 by t minus 1, that is 1 minus t by t. 1 minus t by t. Therefore, 1 minus t by t whole square plus 2. So I can write here minus 1 by t square dt. And no, we can cancel here. We can cancel 1 t. Therefore, it is coming 1 by t dt. And if we calculate, that is t square minus 2t plus 1 plus 2t square, total divided by another t coming out of the root of r. So this is taken in such a way that 1 by t should be cancelled and we are getting the direct whole square and absorb all the x to make a whole square. Outside there will be the constant and we will get that previous formulas. That should be our target. Okay. So I am just cancelling here. It is getting cancelled. Therefore I can write here minus dt by 3t square minus 2t plus 1. Same thing, same as this previous sum. Just take t3 common and absorb all that to make the whole square. Now outside exactly like the previous sum. Okay, I am showing you one more question. Suppose integration dx by x into root over of 1 minus x square. It is also in the form of dx by linear into root over of quadratic. It is in the form. So same thing, I can take it x equal to 1 by t. So dx equal to minus 1 by t square dt. Therefore I can write minus 1 by t square dt. Total divided by, what will do? X is 1 by t root over of 1 minus 1 by t square. So ek to 1 by t will be cancelled out. We are getting minus 1 by t dt root over of t square minus 1 by t, and it is getting also cancelled. We are getting directly root over x square minus x square का formula. So what will be there? That is क्या होगा ये? Log of x plus root over x square minus x square. So in this case the final answer will be log ln, same thing. So t plus root over of t square minus 1. This is the general rule of solving this type of sum. But always, if you want to solve in the entrance examination, there is some another way. What is the another way? Another way is that always your attempt will be, whenever there is a root case, your attempt always, your target should be to substitute for something. It will be the best process for us. What will do today? Just see one thing. Once again I am writing the sum. Dx by, what is there? X into root over of 1 minus x square. Achha, if we take x equal to sin theta, so dx equal to cos theta d theta. So I can write here dx के जगह पे cos theta d theta, x is sin theta, root over of 1 minus cos square theta, that is the sin theta, 1 minus cos square, 1 minus sin square theta, and the numerator denominator will be cancelled. Always for any entrance examination, whenever you sit in any entrance examination, your target will be to substitute for something. Otherwise, you have to lose so much time. So cos theta d theta by sin theta into 1 minus sin square theta is cos square theta, root over of cos square theta is cos theta. So this is coming cos theta and they are getting cancelled. So 1 by sin theta is cosec theta. So integration of cosec theta. Log 10 x by log 10 theta by 2 plus c. Otherwise minus log of cosec theta plus 1.